Okay, guys. So I'm trusting everyone received their corrected test in email. Otherwise, this is going to be it's not as nearly as useful. Uh, it's perfectly okay to ask me questions about your test. I mean, I don't want to get too much into why did I judge the number of points that I did. But I mean, we can do it. You can say a little bit. Why did you take two off? I do have your actual tests right next to me. So, um, although I will have to find them because I have 22 of them here, we can, go through it that way. So, by the way, sometimes in an online situation, what I will do is besides sending you your test, I will also send the answer key. Well, this time, because we are going to be together online, I'm just going to show you my answer key. So let's get into that right now then. So the beginning of the test, hopefully you can all see this. The first question was true or false, and if it's false, explain why or give an example that shows it's false. Is a limit always equal to the actual function value at that time? Normally it is, but not when there's, for example, a hole in the graph. So I wrote false, and my example is an example of a straight line that has a hole in it. And you can see if you look at the function itself, x squared plus 2x plus 1 is just x plus 1 squared. And so the x plus 1's cancel, and you get the limit. I mean, it's just y equals x plus 1, so it's a straight line with a slope of 1 and a y-intercept of 1. However, as you can see from the original statement here in the diameter, I'm sorry, in the original statement here, let me grab my pen. In this statement right here, you can see that x cannot equal -1. So what that means is you have a straight line, but it has a hole in it. So the limit of this function clearly as x approaches -1 is 0, and this is a perfectly valid calculation, but f of -1 is not 0. It's just undefined. And so that was one. There were other ways to answer it, but that was, I thought, the most obvious. So even though the graph approaches 0 from both sides, so it has both side limits equal to 0, it's still not continuous, and it's not equal to the value. So anyway, that's what I was hoping for on number 1. Anybody want to raise a question regarding number 1? Number 2, we had talked about being ready to do a difference quotient. So I threw a difference quotient out here for you. I'll be honest, this didn't go so hot. I was a little bit surprised. So when you plug in your x plus h, of course, now I did an extra step here. So if you look right here, I already squared the x plus h. And where some of the problem comes in, when you square x plus h, you do not get x squared plus h squared. You've got that double middle term, 2xh. So anyway, 2 times that thing squared minus that thing, so I substituted it here to plus 3. And then I just multiplied out the distributive property here, took 2 times each of those things in parentheses. And then I used the vertical form of subtracting the original function here, which left me with 4xh plus 2h squared minus h. And of course, I dare not forget about the h that was in the original expression. And you're bailed out, just like Mrs. Stern talked about this too. You know that denominator, you'd be stuck because you can't have that h down there, and you can factor it out of the top, cancel it, and final result, 4x plus 2h minus 1. So that was the only three-pointer. Why? Because it took a little while to develop, I guess, mostly. And it's so important to our course. Any questions or comments regarding number 2? Let's take a look at number 3. So here was I was trying to get you guys to visually do some limits, so you didn't really have to do any calculating here, I was hoping. So in part A, you're looking at this graph and you're saying, what's the limit of that function as t approaches 0? And the main problem here is if you approach 0 from the left, the limit is negative infinity, as we are headed downward big time. And as you approach it from the right, we're heading toward positive infinity, and obviously they don't agree, so we have to say the limit does not exist. And then on part B, what's the limit of the function as t approaches negative 1? Well, negative 1 is right here, and you can see we first of all, we have agreement between left and right, because from both the left and the right, it's approaching the height of 0. And that's, in fact, the result. Remember, when you're doing a limit, you're trying to find the height. Some of you, or at least one of you, put down negative 1 here. Yeah, as t approaches negative 1, yes, it approaches negative 1, but it's the function it's what's the limit of the function, the height, as t approaches. So anyway, that was number 3. Again, I'll pause. Anyone? Okay, number 4. Yeah, this is the one that, well, only 2 people got correct, which I was really disappointed in. It's actually extremely basic. It's saying what happens to that quantity there, x cubed minus 7x minus 9 over x minus 1. What happens to that as y approaches 1? There's no equation here. There's just an expression in x. And y could do an Irish jig. It doesn't affect that expression at all, and that's why, notice the answer is, it doesn't affect it at all. It's the same expression. A bunch of you, it was the very first thing I taught in limits, and so obviously, I don't know, some didn't impress you very much. If you look, here's the book on page 79. This is where this all occurred, and it was the first time. Up until then, we had been doing limits visually and using tables. But we started doing the properties of limits. Well, yeah, here, let me go to a bigger, here it is in large notation. So if you look right here, the very first example, what happens to B as x approaches C? And the answer is absolutely nothing. So x doesn't really affect B at all, and that's the idea. And then in the book on the same page 79, they gave this example. What happens to 3 as x approaches 2? Nothing. So anyway, yeah, that's all there was to that one. Now, I will say this. If there's one thing maybe I regret a little bit in how I wrote the test, I should have maybe used something other than y right here. I was just picking something different. I should have maybe said q or j or something, because I got, maybe some of you thought, oh, this is like y equals such and such x, and but there is no equation there. You got to remember, it's just an expression that you're trying to find the limit of. So anyway, I know you guys were thinking factoring and all those important things, and Well, you didn't need to be, but anyway. By the way, yeah. Anyway, but did all of you see? I'm going to put a little interjection in here. Did you notice I rarely curve tests, but did you notice I did that here? And I don't want to spend a lot of time on it, but over the years, I developed my own little system for adjusting grades, and it's based on two things: the average of the class on the test and the high grade on the test. And then I have targets for those. You know, the high grade of the test, I figure, should be somewhere in the A category. And the average grade on the test could be anywhere from C to B. And if those targets are off, then I kind of adjust everybody proportionally. Like I said, I don't do this very often, but I decided to this time. So the circled grade on your test is the one that's your test grade, and that's the one, if you go look in Moodle grading, you'll see that's the grade that should be in there. All right, look at number 5. What's the limit of x cubed minus 7x minus 9 as x approaches -1? Well, this should have been the next easiest one because all you had to do is substitute. So I don't think anybody had trouble with that one, -3. And number 6, as x approaches 3/2, what's the limit of 8x cubed minus 27 over 2x minus 3? Well, you can't substitute because it would create a 0 in the denominator, but the numerator is factorable. That's that sum and difference of 2 cubes that, I don't know, evidently some of you never quite caught on to all the way. But anyway, the 2x minus 3's do cancel, and then you can substitute, and the limit is 27. So that's the front page. Let me pause again. Any questions you want to bring up on the first page? I'm going to just take a peek here. Let's see. And we still don't have very many people here. Not so great. Okay. Well, let's go to the second page. Second page. Number 7, way up there at the top. Here I asked you to find the limit of the square root of 4 plus x minus 2 all over x as x approaches 0. Can't substitute. Factoring doesn't help. This is the perfect time for the conjugate solution. That is, multiply top and bottom by the conjugate of the top with the hopes that we can get that x out from under the root sign and eventually cancel this. This is the problem right here, right? This x. That's the problem. Because as x approaches 0, we've got junk if we can't get rid of that x. Well, it works because on the top, some of you forgot how to multiply conjugates. When you multiply conjugates, you get the difference of 2 squares. And I didn't show you all the detail there, but the square root of 4 plus x squared is 4 plus x. So on the top there, you get 4 plus x. And then you get minus the other thing squared. So that top becomes 4 plus x minus 4, which is just x. So that's where I got that x there. And of course, beautiful, that x now does cancel with the bottom. And now, glory be, you can substitute and not create a 0 in the denominator. Some of you even got to this point and had a little trouble substituting there. When you plug in a 0 for x, it's the square root of 4, which is 2, and 2 plus 2 is 4. So it's just 1/4. So you can see I'm trying to cover the basics. Back here on page 1, I tried to take you got the limits by vision. Number 4 was y doesn't have anything to do with the expression. And then we went to this next easiest one where you can do direct substitution. The number 6 solved by factoring. And then number 7 solved using the conjugate method. Okay, so now we're on to number 8. Well, you can't factor, and conjugates don't do anything here. So you got to go to the estimation technique here. So what's the limit of 1 over the cube root of x squared minus 4 as x approaches 2 left is the problem. So, well, as x approaches 2 from the left, that means it's what? Slightly less than 2. What happens when you square something slightly less than 2? Well, it's going to be slightly less than 4. And something less than 4 minus 4 is going to be a tiny negative. You know, like negative 0.01 or something like that. And then what happens when you take the cube root? First of all, you can take the cube root of a negative, and it's going to be tiny. So that's why I wrote tiny negative on the bottom. And so your estimate is, what's 1 over a really tiny negative number? Negative number, negative infinity. Some of you had the concept but didn't have the sign right here. Okay. 9, I gave you the limit of f of x as x approaches c. The answer is -3. And I gave you the limit of g of x as x approaches c. That's 1/4. So can you find the limit of f of x plus 4g of x as x approaches c? Yeah, this is trying to so this is checking on limit properties. The limit of a sum is the sum of its limits. And so I could literally substitute -3 in for the f of x limit and 1/4 in for the g of x limit, and then basically just do the arithmetic. -3 plus 1, and the result should be -2. So that was kind of checking on basic properties. Maybe that one, if I was going totally in a logical order, that one maybe could have been earlier in the test. But all right, number 10, the limit of the cosine squared of x over x as x approaches 0 from the left. So there's no factoring, no conjugates, so we're going to have to do some kind of an estimation here. So on the top, a little bit of trig action here. Is the cosine of 0. Even though we're not quite there, we're approaching it. The cosine of 0 is 1, right? And so the cosine squared of 0 is also approaching 1. So the top is 1. And on the bottom, we're approaching 0 from the left. So that, because we're approaching it from the left, it's a tiny negative. Right? Because you're approaching 0 from the left. Tiny negative. So 1 over a tiny negative. Here we are with negative huge or negative infinity again. And then number 11, I guess, mostly was a trig question again. Are there any vertical asymptotes here? The cosine of pi x. I'm sorry, the cosecant of pi x. So most of you correctly figured out, oh, that's the same as 1 over the sine of pi x, because cosecant and sine are reciprocals of each other. Okay, so now the question is, a vertical asymptote would occur when we have a 0 in the denominator. So now in your mind, hopefully you're saying, when will the sine of pi x be 0? So back to trig again. When is this sine 0? Well, at 0 degrees, at 180, every time we're on the x-axis. Now, what are those in terms of radians? 0 pi. I should have put the 0 down there too. 0 pi, 1 pi, 2 pi, and basically any whole number multiple of that. So when x is 0, 1, 2, 3, and going on forever, would have been the complete answer here. In fact, we could even go in the negatives, couldn't we? Because -1 pi just means go around the other way. So any any whole number for x will give you a vertical asymptote when you're doing the cosecant. Why? Because the cosecant is the reciprocal of the sine. So that's it. 11 problems, 2 points each, except for number 2, which was 3 points, giving a total of 23 points. Number correct divided by 23 was supposed to be how I got your original percent. And then I analyzed and used a for this time. Okay, questions? I've mentioned to one or I was discussing this with 1 or 2 people. At that time, I didn't know I was going to consider curving. Another thing I sometimes will do, and I'm not going to tell you this yet, but at least it's considered, is I will sometimes drop the low grade in the test category. So that's at least a possibility. I'm not promising that. Because I have curved this test, I may not do that. But it's another thing I consider, try to balance out the difficulty of the test and so forth. By the way, well, yeah, never mind. I was going to make a comment. I didn't have you guys doing proofs, and that would have made the test quite a bit. I tried to be real direct, as you could probably tell, but yeah. I'm a little disappointed in myself that I didn't make some of these basics clear. And who knows, might have something to do with our backgrounds. We showed a few weaknesses in algebra, but anyway, on we go from here. Did anybody want to discuss anything? You're certainly welcome to come and see me about your particular test. I will hand back physically tomorrow morning. And I got a question from Damon this morning online that, you know, there is no assignment from yesterday's guest teacher. I've tried to take the pressure off of her not to have to finish a lesson because she had enough going on with a new technology in front of her and different students and a strange environment and a different. So I'm going to just confirm what she showed to you, and we will finish lesson 3.1 tomorrow, and then we'll consider ourselves to be ready to do assignment problems. So I didn't intend for this to be all me. Anybody? Comment? Question?
Would you scroll down, please, so I could look at 6 again?
You bet. Anyone? Anastasia, excuse me.
Can you
Geneva, were you able to see that now?
Yeah, I just realized I put a negative in where there should have been a positive.
Oh, wonderful. So right at the, you mean in this last stage over here? Whoops.
I had negative 6x instead of positive 6x. My addition was correct in the end.
Oh, right there. I see.
I
So
had it there and it just didn't work quite right.
Yeah, and then it doesn't equal up. I gotcha. So you're right. You weren't the only one. Some people had trouble factoring that difference of 2 cubes. Yep.
Yeah.
Can you show the format of that, like just a blank slate one of how you do the cubic?
Yeah. Yep. Let me make a page here. So I'll just make up a new one. Okay, that's the difference of two cubes, right? So I'll use this as an example. Let me change my color here. So when you have the difference of two cubes, you need a binomial. Wow, I don't know what this strange writing is. Let's try that again. You get a binomial and a trinomial, and for the binomial, you take the cube root of the first term, which would be 3x, and here you take the cube root of that guy. Well, it's 2, and then you keep the sign the same. So negative out here, negative there. And then for the trinomial, you take this guy and square him. You take this guy and square him. And then in the middle, you take the product of the two. 3x times 2 is 6x. And then this sign right here, and this is where Geneva had a little problem, is always the opposite of that one. So here, let me do it in general. So here, and just to make sure, let's do a sum of two cubes this time. Okay, so again, you've got your binomial and your trinomial. Take the cube root of the first term and put it here. Take the cube root of the second term, put it here. Keep the sign the same, plus. Then over here, take the a and square it. That's this guy, and square it. Take the b and square it. Of course, when you square, it's going to be positive. And then take the product of the two, ab, and make that your middle term. And then this sign right here is the opposite of that one. So we minus. So that's what? The factoring of the sum and difference of two cubes. Anybody else questions? Okay, then I guess we're done early today. Thank you for tuning in. I can tell you this, I'm glad we've done this electronically. Otherwise, we would have wasted kind of, I just sure didn't want to move forward without having this thing looked at first. Yeah, it took a lot of time. It took me about 2.5 hours to get ready for this because I was scanning left and right. But anyway, I think it was worthwhile. And thank you. I don't know where everybody else is, but I will look forward to seeing you tomorrow. Thank you.